going to get started in a few minutes, folks. Sorry, this has been a very busy day. Good evening, ladies and gentlemen. Good evening, ladies and gentlemen. This is Gigaohm Biological. This is high resistance, low noise biological information brought to you by a biologist. This is the mighty Medeski, Martin, and Wood rocking you tonight. Medeski, Martin, and Wood, I believe, from 2009. I got to look that up again. Sorry, I'm a little spacey on that. It is, 2011, 303. 2011 Medeski, Martin, and Wood. There's a fine couple of sets there. I think there's like 3 days in a row they played somewhere, and they just blew the doors off of that place. This is the opening tune from the second night of that weekend, I believe. This is going to be a more abbreviated stream than you might imagine it would be. The reason being that we have some news to share with you. I'm a little bit blown away by it today, but Nerd Has Power and Lee Min Yan got back to me today, and tentatively speaking, they have decided to join the show on Saturday at 11 o'clock. This is very huge news for me because it means I need to get my pull my head out and get my act together and get prepared to have such learned guests on my little, if you can call this a program. They're going to be on Skype. You know, it's going to be a difficult conversation because we're not going to be in the same room. I'm going to try and have as much of the material available on call, and that's going to take a lot of preparation, a lot more preparation than I probably have time for. In terms of the next 5 days, I'm not saying I'm going to do a bunch of other things. But I want to say that more importantly, I kind of just took a shot in the dark and said, hey, would you guys want to talk? And they said yes. And then it kind of went on the back burner for about a month. And then bammo, today I found out that it could be Saturday at 11 o'clock Eastern Standard Time. So if that's the case, I think we're in for a heck of a weekend. And that might mean I can only stream on Thursday. It also means that I already was extremely distracted today, and I have not I have not made enough slides to discuss the entire Corman-Drosten paper review, whatever you want to call it. It's difficult to know what to call this. It's basically the basis of a lawsuit, the basis of a call for a retraction. And in science terms, this is just saying that, pull your paper down because there's so much wrong with it, you can't fix it. And in this case, they're talking about trying to withdraw the paper that describes the PCR test, or describes the methodologies that can be applied to use PCR as a diagnostic or a screening tool for SARS-CoV-2. So why don't we just get into this here? Make sure that we're all on the same page. For those of you who have been here the last couple of days, this is just a recap, but I'm trying to keep myself sort of on point. And the way we're going to stay on point is to keep hammering the same things over and over again, and sharpening these various parts of the blade that's going to be Occam's razor. It's going to cut right to the truth here. And so somebody told me to move myself over to the other side of the screen, and some of these things are going to be over here. So I might just make myself small for this portion because it might just be easier. Again, we need some collective idea of where we've been so we know where we're going to go together. This is kind of hammering on the blue-red thing. It's kind of hammering on, let's get a common idea of what American history is and what our American identity is. And this is a big deal. We're not going to do that tonight. The next thing I think is important is that the human population has not been appropriately informed to understand the pandemic. The truth isn't given away for free on TV or in social media. And if you are not working hard to understand everything, you are not working hard enough to understand anything. And the primary motivation for most of the major players at the moment is either power or profit. Okay, so if we can just this is where we're trying to start. And I think we can agree on the last one that the darkest forms of capitalism are at play here. And if you're not there and you think that everybody on TV has your best interests in mind, and the United States government is made up of altruistic people who have sacrificed their life in service of you, then I have nothing for you. And find another channel. There are many on YouTube. So where are we? Well, my point is this, okay? My point is very, very, very simple in some respects. I am very interested in the idea. Let me see if I can move. It should be this way, I guess. Yep. I am very interested in not being governed by people that I don't elect. And this clown, and I say clown, as a figure of speech. I mean, obviously he's smarter and more successful than me. I mean, he's one of the rulers of the universe, but I don't think he should be, okay? I don't. And the reason why I don't think he should be is because, again, he's connected to a lot of people that I, again, don't want to be ruled by. I don't want to be ruled by the World Economic Forum, and yet here he is shaking hands with Klaus Schwab, the World Economic Forum dude. Like, they're working together on this. Some people asked me the other night, who is they when you're referring to this narrative? These are the people I'm referring to. These are the people I'm referring to. The android on the right and the Amish farmer on the left should not have any control over my life. And yet both of these people have, and their whatever their company is, has massive influence over our nation and massive influence over our social interactions and massive control possibilities over our nation. And so I'm just not interested in these people governing us. So it feels a little bit like Animal Farm. It feels a little bit like we're being misled. It feels a little bit like four legs better. I don't know. I'm not really happy with what's going on here, and I'm not really happy with what's going on with these dudes on the left. And it's dudes. Look, it's dudes, right? So we're all up in arms and angry about about equality and all this other stuff. Like it's the exact dudes that we've been angry about, right? They're all doing it. So what are they selling? This is what they're selling. Masks prevent spread. And even in the absence of symptoms, the virus is spreading very rapidly and killing people. So asymptomatic people are responsible for controlling spread as well. This is all part of this narrative. Masks are part of this narrative. And so notice there, please, those of you who are just joining me or just stumbling upon this channel, I'm not saying that masks are not useful for things, but I am saying that the phenomenon of asymptomatic transmission and the phenomenon of using masks to prevent the spread of an aerosolized virus, these are debatable phenomena. The second pillar of the narrative of these people behind their faded back is that the entire population is equally naive to this virus, so it's just spreading like wildfire. We are just tinder and nutrition, average health, population density, age distributions, they're all irrelevant variables. And finally, RT-PCR can be used to diagnose viral infections accurately, and false results aren't significant because this test is so accurate and the way that we're applying it is so genuinely in our own best interests. No profits, no power involved. That's the narrative that we're trying to take down. I'm trying to replace it with a narrative that's a lot more nuanced and complicated. Masks are appropriate for people with symptoms. Asymptomatic people, as in history, are considered healthy, and we need a preponderance of evidence in order to change that paradigm that asymptomatic people are not healthy. They are healthy. And we're going to talk a little bit maybe tonight before I leave about this JC virus, which I want to cover again on Thursday along with the rest of this paper. But the principle of trying to control asymptomatic spread of a virus is unprecedented and a new idea being put forth to us now, and that this is part of it, and that's why I'm trying to change the rhetoric around this stuff and make it more nuanced so that people can really understand how, by oversimplifying this biology, we've essentially gone and completely undermined our understanding of it. The human population is not uniformly susceptible to the virus. Innate immunity, primarily stemming from previous human coronavirus exposures, provides significant protection. And this is evidence there's evidence across the board from people who work with kids are less vulnerable. Healthcare workers tend to get hit less. And there's a number of papers showing T-cell immunity from people who have been in the same household of people who have been infected. So a lot of what we understand as traditional grandmother biology, what doesn't kill you makes you stronger, is essentially still true, even though now these people here in the animal farm are trying to rewrite this story and make us believe that our immune systems are a highly vulnerable, tissue paper thin layer between us and the terrible hell that is the environment around us. And finally, RT-PCR can be used to verify what a physician has already confirmed has probably a COVID-19-like set of symptoms. And this would be a legitimate use for RT-PCR in combination with changing some of the things that are in the Corman-Drosten report, which we're going to talk about now. So that was this thing, what I did yesterday. I'm just going to go really quick through this. That was the World Economic Forum narrative, and those were the dudes I was showing before. So the last half of this list is that SARS-CoV-2 is going to become endemic. It probably already is. This year's pandemic should be a wake-up call, not so that we vote for Bernie Sanders, but so that we just realize that there's a healthcare crisis in our country that's a combination of our lack of maintenance and investment in our healthcare system, our lack of prioritizing our healthcare system and adequately patrolling and safeguarding our healthcare system from the economic piracy of private equity firms, and also the health education and general nutrition of it that's embedded in our culture is wrong, and we need to come out of that sort of fog and the people that believe it's okay to eat, as long as you only eat fast food a couple times a week, it's okay, and Subway's not fast food. Pandemic is being leveraged to spend trillions of dollars on for-profit healthcare, including tests, unproven therapeutics, and eventually unnecessary vaccines for a virus that's likely derived from a laboratory zoonosis. Well, that speaks for itself, right? That's what I think. And it should be very obvious to you by now, one of the things that is a very big point for me is that nutrition and specific recommendations in regards to vitamins and trace minerals are completely absent from the national dialogue for the last 9 months. Not a whisper, a word, not even one time have we covered vitamin D, zinc, selenium, some, just basics like what are the top 5 things your immune system needs to function strongly? Dr. Fauci? Vaccines, and remdesivir, which is now recommended not by the WHO. Anyway, it's just crazy. I don't have enough time to I could talk for hours on all the things that happen every day. Oh, so now I really do have to move myself over. I did all these the wrong side. Whoops. Sorry, this is going to get a little choppy here. There we go. That's right. It's still baby time in the production of this show, so sorry for the goofy. So I'm not going to be able to get smaller then either. I'm going to be kind of in the way. This is what you see when you go to the website, which is listed below here, and you will find a very well-written report that I think all of you can read. And I think I would recommend that you do. The reason why is because in a couple days I'm going to revisit it again. Tonight I'm just going to tell you a few of the things. We're going to read the abstract and the introduction together, and I'm going to tell you a few of the most important points for me, being a more than bench molecular biologist from my PhD. I did single cell reverse transcriptase PCR, quantitative PCR, for nicotinic receptors in neurons. It's irrelevant what I looked for. The point is that I've used this technique before, and I've had reviewers in a scientific paper tell me that my primers suck before. So I know the kinds of critiques they're talking about here, and although it's been a long time, much of this that they're saying made sense to me from that perspective. So I think I can at least hold your hand through the beginning. You can read it in the next couple days. I can read it more thoroughly in the next couple days, and then we can talk about this and in more detail on Thursday. So what we're doing here, again, it's just saying that they're trying to, I got to get an arrow over here. I don't know which one you can see. Maybe this one, yes. What they're trying to do is send a retraction request letter to the Eurosurveillance Editorial Board. This is the organization that this protocol was submitted to. So they want that reviewed and taken back. Detection of a 2019 novel coronavirus by real-time RT-PCR. Then that's the article they're talking about there. Here, you see that? In light of all the consequences resulting from this very publication for societies worldwide, a group of independent researchers performed a point-by-point review of the aforesaid publication in which, 1, all components of the present test were cross-checked, the RT-qPCR protocol recommendations were assessed with regards to good laboratory practice and parameters examined against relevant scientific literature covering the field. The published reverse transcriptase qPCR as quantitative PCR protocol for detection and diagnostics of 2009 nCoV and the manuscript suffer from numerous technical and scientific errors, including insufficient primer design, a problematic and insufficient RT-qPCR protocol, and the absence of an accurate test validation. So what this purport is going to do then is basically going to take you through 10 major points, analyzing the protocol and showing you or arguing that there are certain crucial errors made such that this protocol cannot be called specific and therefore has likely misdiagnosed many, many people around the world, and then therefore caused the damage of COVID-19 and the pandemic to be much greater again, because the numbers can be miscounted so greatly. So how is this, what are the things they're going to hammer on? Sorry, I can't find my cursor. There we go. So there are 10 fatal problems with the Corman-Drosten paper, which we will outline and explain in greater detail in the following sections. So you will see that the media is going to cover it too like this, I think, in that this website and the report is sometimes referred to by the title of the paper that they're actually trying to get retracted. And that sort of happened here with my show and with the title that I put up on this video as well. So don't make that mistake yourself, and make sure that you make note in your head that the Corman-Drosten paper, Drosten is this German virologist who originally authored, he's the last author, I believe, on this paper. It's his lab that's kind of famous for developing this, infamous for developing this PCR test that the WHO adopted early in the pandemic. So the first major issue is that the novel coronavirus, SARS-CoV-2, is based on in silico sequences. The first and major issue is that it's based on sequences, because at the time neither control materials of infectious or inactivated SARS-CoV-2 or isolated genomic RNA of the virus was available to the authors. So the argument here again is just similar to this RATG13 argument, that the virus exists only in silico, meaning only as a sequence on a keyboard or in a computer, excuse me. So the idea is they're making the argument that if you're going to really validate a PCR test, you're going to have to have a natural source copy of the viral RNA you're trying to replicate, the one that you're trying to find, to verify. And so this is sort of kind of this argument about Cook's postulates, and people can get that intertwined as well. They've taken bronchial lavage from, I believe, infected patients and gotten it to infect monkeys, and so that is in some ways Cook's postulate. And taking viruses from a sequence and growing them in a cell culture. You can't grow them by themselves. You have to grow them in a cell culture. You have to grow them in a host. It's part of the reason why culturing viruses is a little bit of a misnomer. So the idea, again, I don't want to spend too much time on this text because I am going to go fast and wrap it up before Thursday, and Thursday we'll do it more deeply. My point here is to just stress that they're going to go through this deal from step to step, step by step, and try to look at how RT-PCR should be used and how an RT-PCR reaction should be designed. And then what have they done here, which is different? So that's the question at the bottom of this page here. What is important when designing an RT-PCR test, and the quantitative RT-PCR test described in the Corman-Drosten publication. So I just want you to first hear, let's go back.
PCR
hear this.
to estimate all these supposed free viral RNAs that may or may not be there.
So this is, again, the inventor of the PCR test. And what he's going to explain to you is that the PCR test and the strength of this molecular reaction is that it's so sensitive because of the overabundance of primers that it can pick up one molecule in a haystack and bring billions of copies up so that you can measure it, weigh it, sequence it. That was the original idea for PCRs, to take a single molecule of DNA and make enough copies of it so that you could sequence it, so that you could crystallize it, so you could look at it. And the foundation of all of our ability to sequence DNA is the PCR reaction, because we could make large quantities of pure DNA copies, and that's what allows you to quantify it, to sequence it. You couldn't have a single strand of DNA in a little jar, and then in that little jar, it's actually a camera battery. But in this little jar, you would have a DNA molecule, and then you could sequence it. No. You need millions of copies of the same DNA molecule in this little jar before you can sequence it. And so that's the power of PCR. If you have just one molecule, or a molecule with enough overlapping homology that it can kick off the reaction, then a fragment of that molecule will be replicated over and over and over and over and over again. So here he's going to explain to you the idea that once you start using PCR and you just use it indefinitely, you can find anything in anything. And as he describes, it starts to become a bit almost like this Buddhist ideology that everything is found in everything.
I think misuse PCR is not quite. I don't think you can misuse PCR. The result, the interpretation of it. See, if you can say. If they could find this virus in you at all, and with PCR, if you do it well, you can find almost anything in anybody. It starts making you believe in the sort of Buddhist notion that everything is contained in everything else. Right? I mean, because if you can amplify one single molecule up to something that you can really measure, which PCR can do, then there's just very few molecules that you don't have at least one single one of them in your body. Okay, so that can be thought of as a misuse of it, just to claim that it's meaningful. It is. There's very little of what they call HIV, and what's been brought out here by Phil Pott and Isai already. The measurement for it is not exact at all. It's not as good as our measurement for things like apples. An apple is an apple. You can get something that's kind of like, if you got enough things that look kind of like an apple, and you stick them all together, you might think it's an apple. But and HIV is like that. Those tests are all based on things that are invisible, and the results are inferred in a sense. PCR is separate from that. It's just a process that's used to make a whole lot of something out of something. That's what it is. But it's not. It doesn't tell you that you're sick, and it doesn't tell you that the thing you ended up with really was going to hurt you or anything like that.
Okay, so the echo was actually in that video, in case that wasn't obvious. The reason why I keep showing you him is because he's spent so much of his life trying to explain to people how sensitive his reaction hypothetically could be, especially in terms of the AIDS virus, because it was immediately used as a diagnostic there. And in people who were not showing signs of the actual AIDS condition, it became a very, very stigmatizing thing to be HIV positive. Now, I'm just going to tell you a very brief story, and then tomorrow I will finish it. But I want you to understand this in a brief sense so that you get get a point, maybe a big point. There is a virus called the JC virus, okay? And the JC virus is named after John Cunningham, I believe, was the first patient to have been diagnosed or shown to have it. And this virus is found in lots of people. It circulates throughout the population, and it causes nobody any real harm unless they're extremely immunodeficient. But in people with AIDS, people that take immunosuppressive drugs, if they're JC virus positive, the JC virus can cross the blood-brain barrier and cause an extreme inflammation of the brain, in the myelin tissue of the brain. And in MS patients, it can lead to death. In patients on certain drugs, they have to be careful that they're not positive for this virus, or they can get very sick. And worst case scenario usually happens is they die, and then the other half of the people that survive are left severely handicapped and cognitively disabled. It's a nasty thing. Lots of us have this virus in our body right now. It just goes around from person to person. And you could easily make the argument that we should try to develop a vaccine for it to get rid of the virus, so that these people who are immunosuppressed could be protected. But the reason why we don't do that is because no matter how much of the vaccine we put out there, the JC virus would potentially still be there, still come back and get them. And it wouldn't matter really, because we can use PCR to find this in everyone. I wonder if you've ever thought, for example, and I know that there's going to be some very basic arguments against this. I just want you to get your wheels turning here. When's the last time you had a PCR screen for the measles virus? When's the last time they checked you to see if your polio vaccine titers were high enough? When's the last time that they screened you for polio virus with a PCR test? For chickenpox virus? For mumps, measles, or rubella virus? Why don't they ever PCR screen us for these viruses to make sure that we're not carrying them? You need to understand these differences between coronaviruses and these other viruses before you can start to process the subtleties that they're just hand-waving in front of us. All of it's the same. It's all dangerous. Boom. Yesterday or today, Fauci said something about smallpox and measles and polio and vaccines as though it was just we decided to make a vaccine and we did it and it worked. It's very, very difficult to express the kind of absurd simplification that's going on of our immune system, or our immune response, of our symbiotic or whatever you want to call it, our biological relationship with coronaviruses. And it's this, our ignorance of these things as a population is being twisted and turned against us to make us afraid and confused. And they're backing us into a corner, and we're all starting to just kind of buy into this assumption that we need a vaccine in order to walk free again. And this is not true. It might be true from their plan perspective. It might be true from an inevitable perspective, but it's not true from a biological perspective. The world has not become so terrifying. So what is important when designing an RT-PCR test and the quantitative PCR test described in the Corman-Drosten paper? So the first thing is primers and probes. So the primers and probes are the small sequences of DNA that are used as the fishing parts. There's lots and lots of these, and they're all the same. And they're all designed to stick to one specific part of the viral RNA sequence and find it. And if they find it, they'll stick to it. And then through the PCR reaction, that piece will be amplified and you'll get a positive result. The primers must be specific to the target gene you want to amplify. So you can imagine a scenario where if you choose a gene or you choose a part of a gene which has a lot of overlap with other genes, never mind genes in other animals or other species or other viruses. Remember, we're not just talking about viral genes now in your nose. We're talking about mammalian genes and plant genes and any DNA and RNA that's up there, right? So you've got to have primers which are specific enough so that you're not amplifying things you don't want to amplify. And there's other ways to find that out. They must have an optimal GC content relative to the total nitrogenous basis. The reason why is that GC, they make a certain number of hydrogen bonds between them in that double helix. And whether there's 2 hydrogen bonds or 3 hydrogen bonds for each of those bases as you go down the double helix ultimately determines how the melting point of the DNA is. If you heat DNA, the double helix will come apart. This is not a double helix. These are hands, but imagine my hands are a double helix. And so if you have more GC content, then you'll have more hydrogen bonds in that double helix. And so the melting temperature will be higher. And because PCR is a temperature trick, it is using enzymes that work at specific temperatures and using the facts that DNA melts at certain temperatures and comes back together at certain other temperatures. Then having primers which anneal, which join to their target sequence at a preferred temperature, a known temperature, and can come apart at a known temperature is crucial to making each cycle optimally amplify. And for viral diagnostics, at least 3 primer pairs must detect at least 3 viral genes. So this is one of the things that's going on in Italy right now, is that this doctor in Italy claims that at some moment in Italy they stopped requiring three of these transcripts to amplify, but only one of them to amplify. And that's why the cases have now gone up. That's why they're having this lawsuit in Italy, apparently. But I haven't followed up on that one yet. That's just me regurgitating what I read a few days ago, if I'm remembering it right. So just the primers and probes. The second thing is what I mentioned before, is that the temperatures at which the reactions take place. So the melting temperature is all the way up at 92 degrees. The DNA amplification temperature is the amplification temperature at which this enzyme Taq polymerase works. And then the annealing temperature is the temperature at which the primers can float around in the solution and find their target sequences and get ready for Taq polymerase to finish them off, to double everything up. In each cycle this happens. You go up to a melting temperature, then you go down to annealing temperature, and then you go to a replicating temperature. So the amplifying temperature. So the number of amplification cycles is what we've talked about many times before. Essentially, once you start getting into these 35 and plus cycles, it's much more likely that the transcript that you're amplifying is not the one that you want. And even primer dimers with Taq polymerase being very aggressive, if you will, or randomly aggressive, can cause the amplification of some dummy sequences that can be erroneously identified as positive results. And that's what the number 4 is there, molecular biological validations. Amplified PCR products must be validated by either running the products in a gel with a DNA ruler, so that would be equivalent to having a predicted fragment size, and then verifying that. So if I tell you that these primers, if they're amplifying the sequence that I tell you they're amplifying, should amplify a piece of DNA about 50 bases long, or let's say 300 bases long. And so if you amplified a fragment that was only 50 bases long, then that would be considered a negative because it probably wasn't the right sequence. And the only way to verify whether it was just a shortened version of the sequence you wanted or an erroneous sequence would be the last thing there. That's this thing right here. Well, I'm not a weatherman yet. Is the direct DNA sequencing. This is, for me, the thing that I know we always had to do. I can remember at least 5 different times I've been in a seminar where some old molecular biologist in the back room would say, "Did you sequence your PCR products to verify that they are the target sequence indeed?" And you always see the PhD student or the postdoc kind of squirm and be like, "Well, we did look at the fragment uniformity, and it was a very uniform fragment. It was the predicted size." And then you hear that old person in the back say, "No, sorry, if you haven't sequenced it, it's worthless." We're not sequencing any of these. You see plenty of sequences data around, but we're talking about doing millions of tests a day in America alone. If we're doing 2 million tests a day in America, we are not sequencing more than 1,000 of them. That would be my guess. And maybe I'm wrong by a factor of 10, but we're not sequencing enough of these people that are being told that they are positive in order to really tell them that they are positive. And it would be a really nice number to know, right? If they told you that on the PBS NewsHour, would you be upset? "We have now started sequencing all positive cases to be sure that the 3 transcripts that we identify are indeed the viral sequences of interest." Now that would be spectacular, but they're not going to do that. But that's also where we're going to go with this Drosten report, because they're going to show you what's happening here. So that was that list. We're down here now. Positive and negative controls should be specified to confirm and refute specific virus detection. That's number 5 down here. So we have no positive and negative controls in the PCR test, and that is indeed true. You should have some kind of positive control and some kind of negative control always run alongside of it, and we're not doing any of that. And then 6, there should just be a standard operating procedure available so that everybody can replicate these results, even in the presence of no none of the supplied materials. That's the idea there. So let's just go through 2. There are 10 issues in this paper, listed in this paper. We're going to go through 2. And what they do is very rigorously go through the 5 or 6 points that they just made as far as what should be good, and they're going to look at how good they are. So, primer design. The first one is erroneous primer concentrations. I can verify this one for sure because I can remember it and I looked it up in my own work. And this is pretty correct. So, a reliable and accurate PCR test protocol normally designed using between 100 nanomolar and 200 nanomolars per primer. So what this is meaning is that what is the concentration of the primer in the liquid that you put your nose swab in? And if the primer concentrations are too high, they will be able to pick up all kinds of stuff. They will spontaneously amplify things and are much more likely to spontaneously amplify things that are not the sequence of interest. Independent of the specificity of the primers they chose, the concentrations itself are so much higher than they should be that they're most likely going to cause some false positives. And that's a problem, okay? There exists no specified reasons to use these extremely high concentrations of primers in the protocol, and these concentrations lead to an increased unspecific binding and PCR product amplification. Number one source of positives that we don't want, right? This is the whole point. False positives are how they're running this thing, and what fraction of them do they need to have at this stage if the positive rate is like 7% among all of the tests taken, and 5% of those, let's say, out of that 7%, 5% is false positives like this. Now we have a huge problem. But I think what you have to realize is that any significant portion that's false positives is damaging someone's life, costing us money. And that's the trouble with this. So keep going here. Concentration of the primers. Another thing they look at is reaction temperatures. This was number 2. So here, DNA melting temperature, adequately addressed. DNA amplification temperature, adequately addressed. Erroneous GC contents. Remember we talked about the base pairs and about how G and C make a triple hydrogen bond and therefore contribute to a higher melting temperature of the primers. It says here that for an efficient and specific amplification, I'm going to move myself over and shrink myself down a little bit. Sorry. For maximum and efficient and specific amplification, GC content of the primers, whoops, I'm going to get my arrow over here so you can see where I'm reading, should meet a minimum of between 40 and 60% amplification. As indicated in Table 3, 3 of the primers described in the Corman-Drosten paper are not within the range. 2 of the primers have unusually and very low GC values of 28 to 31% for all possible variants of wobble bases, meaning that if you can change these, right? You can bases and the codons that encode the proteins for these, there are wobble bases. There are bases that you can switch and the codon doesn't change. And so when you're designing your primers, you can do that. You can fool around with the wobble bases because they'll still bind, right? And it still get a high enough affinity where the primers will bind. But these are very low, and what this leads to is that when you cool to the temperature where the primers are supposed to bind, then the primers won't behave the same. Perhaps one primer will have a 2 or 3 times greater chance of binding, and this already throws things off a bit. But it could be that one of the primers doesn't even work at the temperature that they've chosen, and that's what we'll start to look at in more detail tomorrow. But these are just 2 of the things, right? This is only 2. Where's my cursor? These are only 2 of the things that could have gone wrong in that paper, right? Just 2 things. Primer concentrations are wrong, way too high. Melting points of the primers are off. So the annealing temperature could be wrong, or the properties of the annealing moment in the reaction cycle could be very wrong. And so there's 8 more things that they cover in this paper, and I think it's really important that you take the time to read it yourself so that you feel comfortable sharing it with your friends. And we'll go through it together very quickly on Thursday. And on Thursday, we're also going to talk a little bit more about this JC virus, just because I think it's really important to make this point. That coronaviruses are just one of hundreds of viruses that circulate in the human population. And you and I have not been paying attention to very much in the last few years related to public health. We do not know how many unknown respiratory failures and diseases there are every year. We don't know how much influenza-like illnesses there are every year. We don't know how many non-influenza pneumonia cases there are every year. We haven't been paying attention. No one's showing this on TV so that we can put this into the context of yearly cycles of life and death in America and on Earth. And the reason why they're not doing that is because they don't want you to understand this. They don't want you to have a biological context within which to understand the pandemic. They want you to be confused and afraid, and they want you to believe that everybody needs a vaccine to save the people who are dying every year. And none of these people are going to stop dying because old people die every year. And this is the horrible truth of it all, that the subtle games that they are playing can be played with very few players and with lots of good faith players, people that think they are really doing it right and they're doing their best. Of the 1.5 million tests that were done today in America, 1 million of them could have been done very well, with very good intentions, with very skilled laboratories, with very good conditions, with very good controls, and with reasonable cycle counts. And the other 500,000 tests, some of that proportion could have been twisted, done wrong incorrectly, done wrong accidentally, and contribute to the 7% of people that end up being diagnosed as positive, and contribute to this narrative that's on the PBS NewsHour every night that we are having this ever-increasing number of cases. When will they compare the hospitalizations in America in December this year to last year? When will they compare the hospitalizations in November this year to last year? When are they going to compare the number of deaths in November from this year to last year? Because these are the kinds of comparisons that are important. If they randomly choose April or May or June and say there are twice as many deaths now than in April and May, what if there's always twice as many deaths in April and May? In November and December as there are in April and May? What if that's the case and you and I don't know it because we're too busy in the rat race living check to check, trying to decide whether we have enough money to go to Whole Foods or if we should just go to Aldi or Shop and Save? Don't forget, folks, that this is an economic thing. This is a money thing. This is a profit thing and a power thing. This is not about biology. It's not about your well-being, and that's how you're going to start to see through it. The report is listed below. You can find that, and please check it out. If you want to support the stream, there are links below as well. I really appreciate those that have supported. You guys are great. The list is there. Every little bit helps. I hope you can see that I'm still trying to reinvest a lot of it into the presentation, because I think jazzing this up helps to get more people here. It helps make it more palatable for your family and friends, maybe perhaps for you to share bits and pieces of these talks, of these discussions. There aren't a lot of questions in the chat, but I have made it possible for me to see the chat. And so although I'm oftentimes trying specifically not to be distracted by it, if you were to pose a question in the chat, it would be answered by me. At least it would be read. So as we go forward in the future, folks, on Thursday, for example, please feel free to put the questions that you have in the chat. We are going to talk about the this review of the Corman-Drosten paper again on Thursday. We are also going to talk about vaccines on Thursday as kind of an introduction, because what my original plan for Saturday was to do an introduction to vaccines. Excuse me again. It's just really dry throat, and it's not COVID, but it's just talking too much. I wanted to give you a basic introduction into the different kinds of vaccines and kind of do it in parallel to Mr. Gates' recent video where he gives you an introduction into the basics of vaccines and try to point out some of the things that he skips on purpose and some of the ways that he's kind of obtuse or disingenuous, and then kind of preview what's going to happen on Saturday, which, don't forget, I just told you a little while ago, is going to be The Nerd Has Power and Li Min Yan, the author of these two papers now, which more or less accuse the Chinese government of being the creator of SARS-CoV-2. I'm having these authors on, of course, as you know, because I've been interested in the origin stories of this. Wow, my voice is failing so much. But I've been interested in the origin story of this virus since the beginning. That's really what got me started with it on the bike and with Dan Sirotkin's paper. And so we're going to cover some of that too. It's going to probably be a long one on Thursday, maybe longer than this one at least, because I really do want to cover this a little bit in an introduction so that on Saturday I don't have to do so much and catch everybody up who's not there yet. But Saturday is going to be interesting. It's going to be very challenging for me. I don't know that I'm the best at it yet because I don't have very much practice with it. I don't think there's going to be much of a language barrier, and I'm not going to try and get her to rehash too many things or get them to rehash too many things that have been hashed before, what I would discuss before. What I'd really like to get them pinned down on the hand behind the curtain. The hand behind the curtain gave me a water. Thank you very much. What I really want to get them down in the weeds about is what sorts of things we can expect about the immunity, what sort of things we can expect about the sort of cross-reactivity of antibodies and another infection, so antibody-dependent enhancement, and also try to get into the weeds a little bit about some of the very specific molecules of this virus, the subproteins of this virus, rather, that are involved in replication and that kind of thing, and whether or not there are signs of purposeful attenuation of the virus in the laboratory. Because I think if we talk about how a laboratory virus might have been optimized to be used in such a way to legitimize a global vaccination program, one of the things you would need is a very stable virus that was sufficiently different from all background viruses so that you could justify the idea that you could track it around. And so historically, coronaviruses don't really present that way because they evolve so quickly and they disappear and appear so quickly that making a vaccine for them isn't really necessary. It doesn't really work because the viruses are either changing or disappearing so rapidly that any vaccine never catches them. And so what is interesting about SARS-CoV-2 is it does seem to be more stable than the average coronavirus, and it does seem to be mutating less than the average coronavirus. And it does seem to have been this stable from the very beginning, which is what Alina Chan's story is all about. She's about trying to find the evolutionary sort of stepwise progression through the human race that was seen with SARS, the original virus. And that was just not seen with this one. And it's considered evidence that this virus was already very well adapted to humans before it appeared, which again would sort of suggest maybe enrichment in a laboratory. Yeah, so I mean, yes, what Sandra is saying there, it's gain of function to enable tracking. I would just say that it could be novelty in terms of sequence to enable tracking. And maybe just also virulence, right? If it spreads fast enough, then it can't change quick enough, and then they can follow it too. But I think there's some relation to the number of hosts and the amount it should change. But again, I'm not a virologist, so now I'm just kind of shooting from the hip there. I think we're going to end it here because we're at like 55 minutes, including the music in the beginning. This was Gigaohm Biological. This was high resistance, low noise news or information stream brought to you by a biologist. You can find me on the interwebs, on PubMed and that kind of thing. I'm a neurobiologist. I'm a recovering neurobiologist, soon to be maybe a recovering academic neurobiologist. I don't know really where this is going to go in the future. But I do know I'm going to be here as often as possible because I think that it helps me to help you find the biological truth in this world today. I really feel like one of the best things that I can do to help myself, I guess, is to kind of work through this and talk it through in front of a camera because, you know, I know you guys are out there, but in reality, this is also just me talking to a camera and trying to work it out in my head. And doing that while with you guys around is just nice. It's the feedback that I get in email is nice. The critiques that I get in the emails are nice. The reminders that I get in the emails are nice. And the concern that I get in the emails is very touching. And all of you have become kind of my friends through all of this, and I hope I've become a little bit of your friend too. And on that note, I would like to leave you and say goodnight. Thursday we'll have another show. Saturday is a big hitter. Hopefully that's going to go through. I'm only saying that because, you know, this is a organization between two people who I believe now are either in Hong Kong or somewhere else. They're in two different places via Skype and some Chinese Skype-like thing called Loot. I'm trying to figure this out. So there's an organization that's kind of coordinating Li Ming Yan's discussions, and that group and me and Nerd Has Power have agreed on 11 o'clock on Saturday. At least they suggested that, and then I responded yes. And so when they come back and officially say yes, I'll be able to tell you on Thursday again. But I can't see that not happening. I'm too into it. So again, thank you very much for joining me, everyone. If you have questions, post them in the chat next time. I didn't see any tonight. That's okay. You were all listening very well, and that's very sweet. Sleep well, ladies and gentlemen. I'll see you on Thursday.